Dear students and learners, this is my second video for the course of Engineering Thermodynamics. Welcome all. Okay. So in the last video, I have thought about the fundamental concept of engineering thermodynamics and the importance of engineering thermodynamics for mechanical engineering domain. Okay. Now, in this video, we will continue the various kinds of systems and their applications. Okay. Um, so already I explained you about the three types of system: closed, open and isolated system. And the examples for closed system could be a cylinder filled with a movable piston and a bomb calorimeter, which is a closed one. Nothing, that is the energy, no mass can enter into the bomb calorimeter. And a motor car battery. Okay, energy can go in or out of the system, but no mass can enter into the system. And a pressure cooker and a kitchen refrigerator. Okay, and ice cream freezer. Okay, so there manual crank operations is possible, but since other mass cannot be transferred into or out of the system. Now the second kind of open system, and I told you other than the closed and isolated system, open system is an important one, since all the engineering applications are coming under this open system, where both energy transfer and mass transfer takes place. Mass means or matters or the particles or the resources or the substances what you are studying. Okay, and energy means heat and work energy. Okay, so here you can see the hot water can be poured more and more here, and the heat energy is being supplied, and the movement of or the activities on the effect of this heat energy could be seen here. Okay, so the energy transfer and mass transfer takes place here. Okay, and another some more types of systems could be homogeneous and heterogeneous system, which you have studied already in your schooling. That homogeneous means system existing in single phase or the uniform composition. Wherever you check, the composition or the chemical distribution of the various ingredients of that system would be uniform, then it is considered as a homogeneous one. It is also existing in single phase. Phase means the physical state of that system. Okay, heterogeneous means system exists in more than one phase and it is not uniform in composition. Okay, and you can also have some more classifications like pure substances and mixtures. Here pure substances means meant for further it is classified into elements and compounds. And elements, again, they could be classified into atomic level and molecular level, as compounds means molecular and ionic. And mixtures means nothing but they will not be chemically bonded. In pure substances, they had the chemical reactions, and they will be existing in some of the elements, composition, the combinations of the particular two or more types of moleculars or atoms. Okay, they would be bonded by chemical reaction. But mixtures means only physical mixing will be there. Okay, homogeneous mixtures or heterogeneous mixtures. Okay, they will not be chemically bonded. Mixtures means. Again, here you can able to see clearly by this picture what is element means. The combination or any molecules or atoms present in the system would be uniform. Compound means here you can see the combinations of the atoms. Okay, and mixtures means here homogeneous means the distribution would be same or in the single phase, uniform throughout the system. Heterogeneous means it is not uniform. Okay, wherever it is not accumulated or distributed and the mixture is not uniform, then we can call it as heterogeneous. And then now Thermodynamic properties. Okay, now you have studied the place where we are concentrating is system. Other than the place of system is considered as a surrounding, the boundary is separating system and the surrounding. And now the property, what would be the property of the substance which you are considering? Could be mass. You know, mass is the quantity of matter in kgs, measured in kgs. Weight is nothing but the force exerted of the on a body by the gravity. Volume is nothing but the space occupied by the matter in meter cube, or meter cube per kg in specific volume. Specific volume, and specific weight is weight per unit volume. Density, you know very well, all these things you would have studied in your schooling itself. Density is mass per volume of substance. Temperature is nothing but the degree of hotness or coldness, that is the unit of measurement for the heat energy. Pressure is the force exerted per unit area. Specific heat is the energy required to rise or lower the temperature of a substance about 1 Kelvin or degree Celsius. Internal energy is the energy contained within the system. Work is a type of energy, heat is a type of energy. Work is movements take place due to the molecular movement, and the heat is flow takes place due to the temperature difference. Okay, so if the temperature, because the molecular temperature difference is the reason for movement of the flow, means then it would be considered as a heat energy. Okay, if the movement takes place due to the molecular activities, means then it is called as work. Okay, enthalpy is the heat content of the system, which is nothing but equal to internal energy plus flow energy. Types of properties. Properties are very important, and their units of measurements are also essential to learn, because unless otherwise you know the units and the unit conversions and the unit simplifications and equalization, you cannot solve the problems in thermodynamics. This is purely a problematic subject. Intensive property and extensive property. Intensive, okay, property is independent of mass of the system. Okay, whether it is 1 kg of water or 2 kg of water or 1000 kg of water, the temperature which you are measuring is same for any mass of the system. Okay, so it is an intensive property. Pressure, density, specific volume, etc. Extensive property means independent on the mass of the system. Volume. 1 kg of water, the space occupied or the volume occupied by 1 kg of water is different from 2 kg of water. So it is purely dependent on the mass of the system. So volume, internal energy, the energy of the molecules. If more substance are there, means then more internal energy would be there, right? Okay, if 2% is there, means the internal energy would be more than single person, right? Okay, so if the property is changing, depends upon the mass of the system, then it is called extensive property, right? Okay, so here you can see the various physical quantities or the properties and their units, SI units. You have to follow the SI unit throughout the course. Pressure and its units. Why we are studying about the pressure is, you know very well, whenever temperature is coming into play, because of the heat energy which we are studying, wherever temperature exists, the pressure also is coming into play, and it's play a key role in all the systems whatever we are going to study. So measurement of this pressure and its units is much important, and you would have studied in your schooling itself. 1 Pascal is equal to 1 Newton per meter square. Is Newton per meter square, how it comes is force exerted by a fluid per unit area. It is also, you should know the bar, and what is the value for 1 atmosphere is 101.325 kilopascal, etc. Okay. Then next step, it's a conversion. You try to learn it. 1 bar equal to 10 power 5 Pascal, which is equal to 100 kilopascal, and 1 atmosphere is equal to 1.01325 bars, which can be converted to kilopascal and Pascal, okay, etc. And types of pressures is absolute, gauge and vacuum. Three types of pressures. From this picture you can able to clearly know this is the atmospheric pressure level. Okay, this is the atmospheric pressure, and if you want to get the absolute pressure, this atmospheric pressure should be added with the gauge pressure. Atmospheric pressure plus gauge pressure will give you absolute pressure. Okay, if it is lower than, if the pressure existing lower than the atmospheric pressure, means then the absolute pressure would be atmospheric pressure minus vacuum pressure. Okay, so this is negative atmospheric pressure, this is positive atmospheric pressure. This the lower than this blue line you can have the negative pressures. Okay. So vacuum pressure means pressure below the atmospheric level. Vacuum pressure, that vacuum pressure would be got by atmospheric pressure minus absolute pressure. Okay. Temperature and its measurement. As we have studied about the pressure measurement, temperature measurement is also very important, because the heat energy what we are supplying is measured in terms of temperatures only, which is defined as degree of hotness or coldness, which is measured in Kelvin, either Kelvin or degree Celsius. So you know very well that 0 degree Celsius is equal to 273 Kelvin. Okay, and here you can able to see 0 degree Celsius is equal to 273 Kelvin, and 100 degree Celsius is 373 Kelvin. This is freezing point of water, this is boiling point of water, and initial, that is in Fahrenheit, 0 degree Celsius is equal to 32 degree Fahrenheit, and 100 degree Celsius is considered as 212 degree Fahrenheit. Okay, and specific heat of capacity. Specific heat capacity. Specific heat capacity, by the term itself you come to know heat capacity, which is specific, is quantity of heat required to rise the temperature of the unit mass of material through 1 degree Celsius. Okay, so if you want to increase the temperature of 1 degree Celsius for 1 kg of water or rice, how much amount of heat is required is called as specific heat capacity. Okay, so this is this you can have in two types: specific heat at constant pressure and specific heat at constant volume, CP and CV. These terms you will continuously use it for all types of calculations and throughout this course. Okay, CP for air is equal to 1.003 kilojoules per kilogram Kelvin, CV is equal to 0.71 kilojoules per kilogram Kelvin, and you can have the universal gas constant capital R is equal to CP minus CV. Okay, and now we are entering into the very important definitions or the terminologies which we are going to use in this thermodynamics, as state, what is processes, what is cycles. Okay, state is a condition. State, what is your state? How is your mood? Like that your friend is asking, no, at that particular time, what is the status, what is the state of your mind, physical health with respect to the surroundings. Okay, how about you on that particular situation? Like that, what is the state of that system which you are considering at a particular time? Okay, so it's a condition of a system as defined by the values of its property, which gives a complete description of the system, which gives a complete description about how that system is described by the state. Okay, process is defined as when any change that a system undergoes from one equilibrium state to another. Okay, So thanks for patience listening, and we will continue in the next third video of engineering thermodynamics. And in this video I